Hi my dear children, I hope you all will be healthy. In this video session, you are all going to learn the lesson Forces and Motion from Physics. Come, let's move to the lesson. Unit 2, Forces and Motion. Students, come let's see the lesson Forces and Motion. Introduction. You have already learned in your earlier classes that what is push and pull. What happens when you push an object? It moves, isn't it? Yes. And what happens when you pull an object? It also moves. So, push or pull results in some motion of the object. So, what is force? Force is nothing but is an action of push or pull which makes the object to move or brings the moving object to rest. Example: when we open the door, kick a football, lift a school bag, writing with our pen, opening a pen, everything involve a motion, and that is some push or pull. Motion and rest. What is rest and what is motion? Come, let's see an example to understand the motion and rest. Suppose there is a book on your table right in the middle. Is the book moving? You will say it is not moving, it is at rest. If you push the book to one side of the table, you will say the book is moving. When the book was at the same place with respect to the table, you say the book was at rest. But when it was pushed from one place on the table to another place, you say it was moving. So, what is motion and rest? When there is a change of position of an object with respect to time, then it is called motion. If it remains stationary, it is called rest. Observe the following pictures and say whether the objects are in motion or at rest. The first picture, the man in a boat. Is he moving or at rest? The man in the boat is moving with respect to the bank of river, but he is rest with respect to the boat. Is it? Yes. Next, the girl on a swing. Is she moving or at rest? Yes, here also, the girl on the swing is at rest with respect to the seat of the swing, but she is moving with respect to the garden. Next, the girl on the bicycle riding to her grandmother's house. Here, the girl on the bicycle is moving with respect to the road, but she is at rest with respect to the bicycle. Take the case of a book on a table at rest. It is really without any motion. We know that Earth is rotating on its axis. Therefore, the table along with the book must be rotating, is it not? We are also moving along with the Earth. Therefore, from the point of view of ground on which we stand, the book is at rest. Similarly, while traveling in a speeding bus, we feel that the poles and trains seems to move backwards and the things inside the bus are stationary. So, an object may appear to be stationary for one observer and appear to be moving for another. An object is at rest in relation to a certain set of objects and moving in relation to another set of objects. So, this implies that rest and motion are relative. How things move. When we kick a ball, it moves. When we push the book on the table, it moves. When a bullock pulls the cart, it moves. So, motion occurs when the object is pulled or pushed by an agency. So, who are the agencies here? Yes, the human being and the animal. In daily life, we pulled out water from the well with bucket, or the animals pulls a bullock cart. It is a person or animal that is an animate agency that does the pulling or pushing. Sometimes we see a tall grass in the meadow dancing in the wind, and a flag flutters in the wind. A piece of wood is moving down a stream. What pushes or pulls them? We know that blowing wind and flowing water is the cause. Sometimes the push or pull can be due to the inanimate agency, like wind and water. So, forces are push or pull by an animate or inanimate agency. Contact and non contact forces. Contact force. In all the cases we have seen, like bullock pulling the cart, fluttering a flag, kicking a ball, pulling water from the well, riding bicycle, the force is executed by touching the body. So, this type of force is called contact force. Non contact forces. Mysteriously, ripened fruit falls to the ground. What pulls it to the ground? We would have heard of the force of gravity of Earth. Gravity pulls the ripened fruit from the tree to the ground. Next, bring a magnet near the small iron nail. Suddenly, the nail jumps into the air and sticks with the magnet. Observe that the magnet and the nail did not touch each other. Still, there was a pulling force that made the nail to jump towards the magnet. In these two examples, the force is applied without touching the object. Such forces are known as non contact forces. Forces can be classified into two major types: contact and non contact forces. Wind is making a flutter, a cord pulled by a bullock, or contact forces, magnetism, gravity, or some examples of non contact forces. So far, we have seen the agencies of force and the type of force. Forces are push or pull by an animate or inanimate agencies. Based on the basis of contact, the forces are classified into two types. They are contact force and non-contact forces. What happens when we apply a force on an object? Say you kick a ball which is at rest. The ball moves. So, here the application of force in an object results in motion from a state of rest. Next, what happens when a batsman hit a ball? The ball already in motion, but with a strike, the speed of the ball increases. Moreover, the direction of the ball changes. So here, the application of force on object results in a change in its speed and change in its direction. Next, crush a balloon, apply force on roti duff, pull a rubber band. In these cases, the shape of the object change on application of force. So here, the application of force in object results in expansion or contraction. The person in a bullock cart is applying force to stop the cart from moving. What happens now? The force is applied against the direction of the motion. The speed can be reduced or even motion stopped completely. Next, when you apply brake in speeding bicycle, what will happen? The bicycle stops suddenly and you may fall down. So, the applied force in an interaction of one object on another that causes the second object to move from rest or speed up, slow down, stop the motion, change the direction, compress or expand. So, forces can change the states of body from rest to motion or motion to rest. It can either change the speed or direction or both of the body. Forces can change the shape of the body. Types of motion. You can classify the motion according to the path taken by the object. They are linear motion, curvilinear, circular, rotatory, oscillatory, and zigzag. The first one, linear motion. Here, the object is moving in a straight line, like a person walking on a straight path, and free fall. Curvilinear motion. It is the motion of a body in a curved line, moving ahead but changing its direction like a throwing ball. Circular motion. Here, the object is moving in a circle, like swirling stone tied to the rope, and the person's moving in a merry-go-round. Rotatory motion. The movement of a body about its own axis like a rotating top and rotating merry-go-round. Oscillatory motion. Here, the object coming back to the same position after a fixed time interval like a pendulum. Do you know the fast oscillation are referred to as vibrations? Zigzag motion. Here, the motion is not in a proper path, like the motion of a bee or people walking in a crowded street. Zigzag motion is the combination of all motions. Periodic and non periodic motions. Take the case of the hour hand of a clock. In one day, it makes two rounds. Look at a bouncing ball. It bounces a certain number of times for a given time interval or period. Look at the water waves. In a given period, that is a time interval, a fixed number of waves hit the shore. Motion repeated in equal intervals of time is called as periodic motion. What is non-periodic motion? Let us take the example of sabbing, swing and wind. This motion is not in uniform interval. Such motions are called non-periodic motion. Do you notice that all oscillatory motions are periodic? But not all the periodic are oscillatory. Example, revolution of the moon around the earth is periodic but not oscillatory. However, the children playing in a swing is both periodic and oscillatory. Fast versus slow. Look at the tall tree. When the wind is gentle, its branches are dancing slowly. But if the gentle wind becomes strong, the branches shake violently. And if the speed increases further, the branch may even break and fall. That is, the motion can be slow or fast. Can we say a motion is slow or fast without comparing anything? Yes. Compared to walking, cycling is fast. But a bus is faster than a cycle. The aeroplane is much faster than a bus. So, slow or fast is relative concept which depends upon the motions we are comparing. Average speed. By calculating the average speed of an object, we can say which object is moving slow and which object is moving fast. So, what is the definition of speed? The distance traveled by an object in unit time is called average speed of the object. If an object traveled a distance d in time t, then it is average speed s is equals to distance traveled by time taken, that is d by t. SI unit of distance is meter and the unit of time is second. So, the SI unit of average speed is meter per second. Come, let's calculate the average speed of these vehicles. See, here the taxi driver says I have traveled 160 km in 2 hours, and the bus driver says I have traveled 200 km in 4 hours, and the truck driver says I have traveled 300 km in 5 hours. Can you say who traveled with highest speed? Then how do we say a body moves in a particular speed? Yes, by calculating the average speed of the vehicle. So what is the formula to calculate the average speed of the vehicle? Yes, is distance traveled by time taken. Is it? So, distance traveled by the car is 160 kilometer and the time taken is 2 hours. So 160 by 2, it is 80 kilometer per hour. Then the distance traveled by the bus is 200 kilometer and the time taken is 4 hours. So 200 by 4, is 50 km per hour. Then distance traveled by the truck is 300 km and the time taken is 5 hours. So 300 by 5 is 60 km per hour. Now you say which is fastest and which is slowest? Yes, car traveled in highest speed. That means 80 km per hour. And bus is the slowest one, 50 km per hour. Suppose a car travels 300 km in 1 hour, then we say the speed of the car is 300 kmph. So how to read it? 300 kilometers per hour. Then, if an object traveled 10 meters in 2 seconds, then the average speed is equals to distance traveled by time taken. So what is the distance traveled? It is 10 meter and the time taken is 2 seconds. So 10 meter by 2 seconds is equals to 5 meter per second. Next, bus takes 3 hours to cover this distance of 180 kilometers. Then its average speed is distance traveled by time taken. Here, what is the distance traveled? 180 kilometer and the time taken is 3 hours. So 180 by 3 is equals to 60 kilometer per hour. Note, if we denote the distance in meter and time by seconds, then the unit of average speed is meter per second. If we denote the distance in kilometer and time in hour, then the unit of average speed is kilometer per hour. We know speed is equals to distance traveled by time taken. That is S is equals to d by t. So if we want to know the distance traveled, we take out the d. So the formula will be S into t is equals to d. Therefore, the distance traveled is speed into time. See, for example, if a ship traveled at a speed of 50 km per hour and it sailed for 5 hours, how much distance it had traveled? Here, what is the speed of the ship? Is 50 km and the time is 5 hours. Here, speed into time is given and as to calculate the distance. So, what's the formula to calculate the distance? Is speed into time. So 50 km per hour into 5 hours is equals to 250 km. Here hour and hour is going to be cancelled. Then if we know the speed and distance travelled, we can compute the time taken. So how the formula will be? T is equals to D by S. So time taken is equals to distance travelled by speed. For example, suppose a bus travels at a speed of 50 km per hour and has to cover a distance of 300 km. How much time it will take? See, here the speed of the bus is given, it is 50 km per hour and the distance covered is 300 km. So what's the formula to calculate the time? T is equals to D by S. So 300 km per 50 km per hour. So what's the answer? Is 6 hours. Here kilometer and kilometer is going to be cancelled. Uniform and non-uniform motion. Suppose a train leaves Tiruchirappalli and arrives at Madurai. Is the train travelled in an uniform speed? First, the train was stationary. When the train left the station, the motion was slow, and only after it left some distance that it gathered speed. After that, it slowed down while crossing bridges and stopped at intermediate stations for passengers. Finally, as the train approached Madurai, again it slowed and finally came to a halt. That is, the speed was not same all through the journey time. That is, the speed was non-uniform. This motion is said to be non-uniform motion. However, in between the journey, there may have a stretch wherein the train might have been going at a constant speed. During that interval, the train was moving at uniform speed, that is, uniform motion. If an object covers uniform distances in uniform intervals, then the motion of the object is called uniform motion. Otherwise, the motion is called non-uniform motion. The next interesting topic is about robots. Robots are automatic machines. Some robots can perform mechanical and repetitive jobs faster, more accurately than people. Robots can also handle dangerous material and explore distant planets. The term comes from Czech word robota, meaning forced labor. Robotics is the science and study of robots. A bipedal humanoid robot is given in the picture. Robots can sense and respond to their surroundings. They can handle delicate objects or apply great force. For example, to perform eye operations guided by a human surgeon or to assemble a car. With artificial intelligence, robots will also be able to make decisions for themselves. Electronic sensors are a robot's eyes and ears. Twin video cameras give the robot a 3D view of the world. Microphone detects sounds. Pressure sensors give the robot a sense of touch to judge how hard to grip an egg or heavy luggage. Built-in computers send and receive information with radio waves. The quadrupedal robots are used in militaries. Artificial intelligence attempt to create computer programs and think like human brains. Current research has not achieved this, but some computers can be programmed to recognize faces in a crowd. Robots can think, they can play complex games such as chess better than human beings and used in the industries to do the welding. Articulated welding robots are used in industries. But will a robot ever know that it is thinking? Humans are conscious, we know we are thinking, but we don't know how consciousness works. We don't know if robots can ever be conscious. The next interesting topic is about nanorobotics. Nanorobots or nanobots are robots scaled down to microscopic size in order to put them into very small spaces to perform a function. Future nanobots could be placed in the bloodstream to perform surgical procedures that are too delicate or too difficult for standard surgery. Imagine if a nanobot could target cancer cells and destroy them without touching the healthy cells nearby. It will be more useful.